All right, in this video, I'm going to go over Apex section 10.2.1 sound, and this is part 2, so continuing from part 1 in the previous video. So in this, I want to start off by talking about intensity. Intensity is the amount of energy of a sound wave that it carries past a certain area in a given amount of time. So if you have a high intensity wave, that's going to be a wave that has high energy, and it's also going to be louder. So intensity is related to amplitude. If you have a low intensity wave, it's going to be low energy, and it's going to be a quieter sound. Okay? The unit we measure decibel intensity in is called the decibel, okay? Intensity is measured in decibels, which we abbreviate dB, okay? And so the idea here is there's something that creates a sound, and that sound wave travels outwards. And as it travels away from the source, it becomes more spread out and less intense. Let me write that down. So as a sound travels away from a source, it becomes more spread out and less intense. And I'm going to say intensity decreases as the square of distance. So let me explain what that means. Okay, so let's say you have a drum. Right, this is our drum and we hit it. Okay, and our sound wave goes out, right? So as our sound wave goes out, it becomes less and less intense. Okay, so for example, if you are 1 meter away and it's 4 decibels, then when you're over here and you're 2 meters away, how many decibels will it be? Well, we just doubled the distance. So that means you need to divide by 2 squared. So you're divided by 4, so you get 1 decibel. Okay, this should have been capitalized. Okay, so this is what I mean by intensity decreases as the square of distance. As you move away, it becomes less intense, the sound wave spreads out more. So if you double the distance, the intensity is going to decrease by 1/4. Okay, that's what that means. All right, so that is everything about intensity. The next thing I want to talk about is the Doppler effect. Now, we have all experienced the Doppler effect. I'm going to show you a little video example of this. So this is of a train. Okay.
Away from the edge of platform 2.
Okay, we have our train approaching. I want you to listen to the train whistle as the train goes by. Okay, so we should have noticed that it goes, as it's approaching you, it goes ee-oo, right? And then it goes past you and that sound drops. You've probably heard this if an ambulance drove by you, or if you've went past a train, that ee-oo, right? That's called the Doppler effect. So we want to be able to use sound waves to explain this. So I like to start explaining Doppler effect by talking about a duck sitting in a pond. Okay, so this is our duck. As usual, my drawing is poor, but you can see it's a duck. And if a duck is sitting in a pond, it'll have nice little ripples going around it. Right? It's bobbing up and down, and it's producing these ripples, these waves. Okay? But now we can say our duck wants to move this way. So now, once our duck starts moving, we again have our duck. Oops. In our pond. And now what's going to happen is the ripples in front of the duck start to bunch up. You've probably seen this before. That if a duck starts moving to the right, those ripples in front start to bunch up, and then behind it spreads out. Okay? Okay, so since the duck is moving this way, the ripples in front of the duck start to bunch up, all right? They would have been just equally spread apart, but it's moving now, so the ripples bunch up. And that means that the ripples behind start to spread out, okay? Because of this, we have a higher frequency of waves, these ripples, in the front as the duck approaches you. And behind the duck, as the duck leaves you, you get a lower frequency of ripples. And this is the Doppler effect. When something is moving in front of it, the ripples or the waves start to bunch up, and behind it, they start to spread out. So let's look at an example of that. Okay, so here we have this car. It's moving. It's producing sound waves. And you notice in front of the car, the sound waves start to bunch up, okay? And you see here that as the car is coming towards you, the sound waves bunch up so you get a high frequency. As the car is moving away from you, the sound waves spread out so you get a low frequency. And if you remember, high frequency is a high pitch. That E, low frequency is a low pitch. Ooh, right? So as something is coming towards you, first you get that high frequency of all those waves bunched up, that E, and then as it goes past you, you get the low frequency of the waves spread out, ooh, right? So that's why we hear that ew, right? You have a high frequency at the beginning and then a low frequency behind it, okay? So this is what the Doppler effect is. As something is moving, the waves in front of it, as you're approaching it, bunch up so you get a high frequency, which leads to a high pitch noise, and then behind it, the waves spread out so you get a lower frequency, which causes a lower pitch. So that's called the Doppler effect. So we need to understand the Doppler effect, what I just explained here, and we need to understand intensity, especially that intensity decreases as the square of distance. Thank you.